This is our spring 2023 capstone project. We are team 6 and our team includes Alexis Ashton, Maggie Brown, Lance Borman, and Hector Rivera Hernandez. Our client was Pella Windows and Doors, and their headquarters are located in Pella, Iowa. And our project was the Lumber Plant Warehouse Improvement Project.
This video breakdown will include the project background, current state, solution approach, future state, and then we'll end with additional insight.
In our time with this Pella project, we were given some primary objectives, and with that was to increase the lumber warehouse capacity by 30% based on floor square footage savings. And in order to do this, we had a kind of a secondary objective that was to justify the implementation of comb lifts with a 2-year payback period, and this would help us with the floor space savings as well. To begin our project, we wanted to get a feel for what it was actually like out there at the current time, thus our current state analysis. We took a look at the front area, or hot box, which is the top chart you can see there, and then the bottom chart was another storage area we were also focusing on. Additionally, we wanted to kind of determine how long it took to pick parts in each of the different areas. So we took measurements for both short boards as well as long boards for both the warehouse and production side of things, and we found out that the short boards were a bit easier to maneuver around the warehouse than the long boards, and you can see in the charts here the data to back that up.
When it came to the solution approach, we first started working with the redesigning of the warehouse. We wanted to provide Pella with 30% more space in a 2-year payback period with implementing of the combi lifts. As we noticed, we were not able to achieve the 30% space savings that they wanted, as well as a 2-year payback period, which can be observed in the combi lifts implemented in payback period table. Knowing that we could not justify the objectives, we focused on improving areas that would result in savings.
With this, we were able to look at the density data that we were able to record in the warehouse, as well as the demand that they were able to provide, for us to better understand how those fit together and where did we see the biggest variations between a low storage and a high demand for those parts. This presented us with the opportunity for relocating some of these parts and be able to attain some of the space savings. With this, we used the 80-20 rule, which essentially said that if we were able to identify the top 20% of the most picked parts from that demand data, we were able to relocate these parts and actually impact 80% of the material handling that went about in the warehouse. With this final design, we were able to incorporate these ideas without implementing any combi lifts.
In our future state, we have provided our final layout design. This includes the hot box design, and where we essentially put the 80% most demand parts in there. As you can see, we were able to efficiently save space in the back end of the warehouse because these heavily dense parts were able to fit more cohesively in the hot box, and we were able to save about 2,100 square foot of space, the green bar in the back, just from rearranging these part numbers. As far as our economic impact for future state design, the total reconfiguration cost mainly came from labor, and that resulted in about $18,000. And then our savings came from 2 different aspects. The first was the aisle travel time. Our forklifts were able to save a lot of time by picking up those heavily picked products from the front of the warehouse as opposed to the back. And then the space saved was the 2,100 square foot saved, the green bar in the back of the warehouse. And the total of those 2 savings resulted in about a little over $200,000. And then our ROI for year 1 was 1,290%.
Additionally, we were able to provide a report which gave out the optimal storing recommendations for each part. This would show the optimal number of pallets that you would need in order to maximize each storage method. Not only that, but we were able to identify and categorize each part number into its own ideal storage method based on different criteria and factors that made sense for the warehouse.
We would like to thank our professor, Dr. Dave Sly, as well as Bill Hackford, Steve Lauritzen, and the rest of the Pella team that helped us throughout the duration of our project.